This is chapter 5.3, Logarithmic Functions and Graphs, part 3 of the notes. So if you haven't watched parts 1 and 2, make sure you go back and do that. What we're going to do now is move the equations that we get into different forms. This is going to help us solve equations when we get to that. So right now, these examples 4, 5, 6, and 7 that you're looking at are in logarithmic form because there's a logarithm in that, but we want to move them to exponential form to make it where there's no log, and we want it just in an exponential function. So an easy way to do that is you're going to use an e for exponential. So your exponential is really base to the power of the other side equals the argument. And I'm just going to draw myself an e every single time. So the exponential form of this equation is 2 raised to the 5th power equals 32. Base raised to the exponent of the other side equals the argument every single time. And in this case, 2 to the 5th power is 32. You can also check yourself with that. Now, the only caveat to using our little e as a guideline of what goes where is that the logarithm, the log, has to be on the left. If it's not, then you can't use it. So looking at number 5, our log is not on the left, but you could just flip the entire equation around to do that. Just put your log base 1/2 of 32 on the left equals -5. It's the same thing. It's fine. So just use our e. So it's our base 1/2 to the power of the other side, -5, equals our argument, which is 32. There's our e for exponential form. So that tells us 1/2 to the -5th power equals 32. And again, if you want to, you can pop up your calculator and check that. So we could have 1/2, I'm going to just do 0.5, raised to the -5th power equals 32. There's a good check for that. Now you can't check them if they have exponent or the variables, just like this number 6. So I'm going to go ahead. The log is on the left. So put it in exponential form, use my e. Base to the power of the other side equals the argument. So a to the 8th power, a to the 8th power equals q. That's it. The next one is your turn. Make sure you put the logarithm on the left. Now that we have converted into exponential form, now we're going to be given exponentials and convert them to logarithmic form. Now again, same thing. We're going to use this later to be able to solve for x, but we're going to use an L for logarithmic. Again, the same problem that we had before is that we want the exponential on the left. If the exponential is not on the left, you can't use your L. So this one, the base is still going to be the base. Keep that in mind. So we're going to have log base 5 of argument 25 equals 2. So there it looks kind of like an L if you use your imagination. Some people call it the box method because they think it looks like a box, whatever. So this tells me log base 5 of 25 equals 2. So there's my logarithmic form. One thing I want to point out to you is that this 25 is the argument of the log. It is not a power of the 5. The 5 is a subscript. And in my math lab, you can just click the LOG button and underneath it where you find the fraction and everything else. There's going to be an LOG button for you to push. And if there's no base, you can just type in LOG, or there's 2 different ones for you to choose from. So if you look at example number 9, the exponential is not on the left, so I can't use my L shape to be able to figure out what things are. So the first thing I need to do is take it and put it in the correct format. So 8 to the 2/3 equals 4. Take my L, come straight down, log base 8 of 4 equals 2/3. So again, the base is the same. Log base 8 of 4 equals my power, 2/3. You will always be equal to the power. Looking at number 10, exponential is not on the left. Remember, the exponential is the thing with the exponent, so I'm going to rewrite it. 2 to the x equals 16, and then use my L to put it in logarithmic form. Log base 2 of 16 equals x. And just write it. Log base 2 of 16 equals x. Number 11 is your turn. Now, here's the thing. Log base 10, remember, this is the common log. If it has a base 10, it's a common log. If it's base 10, we're not going to write that base 10. It's understood already. So we're going to write it like this. Log of 0.0001 equals -3. Either answer is correct. My math lab should give you credit for either one. However, the most common way to do this is the second one.